Hi and welcome to Bytes and Bits. A thermal camera is a very useful tool in both electronics and in a whole range of other areas where measuring temperature and testing things out in that way becomes very essential. So luckily a company called HIKMICRO have sent me through their mini thermal imaging camera. And this is a very affordable camera, coming in at about £120. So let's have a look and see what this can do, what's inside the box, and how we can then use that to actually help us in electronics and then a number of other situations. So although this is a lower priced thermal camera, it is actually very high quality, and that becomes apparent right from the sort of first packaging. So it comes in this really nice box, and it's a very nice smooth fit for this one. So let's get that open there. So it comes with a user manual. Again, these cameras do require a bit of knowledge how to set them up. So this will take you through how to install the app and connect it to your phone. Or of course you can download an app for your computer and then connect it directly into there and turn your computer into a thermal imager. And then it then goes on to talk you through how to use the various modes of operation and measurement systems. So we'll have a look at that in a second. The camera itself then comes in a really nice carry case to protect it. So if we open that up, we'll see that our camera itself is underneath this flap in a very well protected padded area here. So if we get that out. So this of course then is the actual camera itself, and this is designed then to either plug into the USB-C port on your phone, so we'll just plug directly in there, or we can plug it into a computer. And to do that, we will need to use these various adapters. So it comes with a range of adapters. So we have a USB-C to USB-C extension little device here. And really what that's for is if you have a case on your camera, this edge of the camera here will probably butt up against your case and you won't get a good connection then through the USB-C port. So what you do with this is you simply plug that in, and we now have an easy way to connect our camera into the phone so that it doesn't interfere with any cases and so on. And you can then, of course, use your phone sort of as a thermal imaging device like that. The other adapter then is for an iPhone. So you can see here that we have a USB-C to the Apple connector. So that will then work, of course, for that. Let's just pop those down here. The last accessory you get with the camera then is this extension cable. So this is a USB-C extension cable. So we can simply plug our camera into one end of that. This then can either go into our phone or of course off to a computer to give us our USB-C connection. And that then allows us to use the camera sort of more as a sort of a handheld camera. So we can go off and we can then look at various circuits or whatever else that you want to look at with your camera. So those are all the parts then that you get with this device. I say it is a really high quality feel to it. So let's have a look at how we can install that onto our phone and onto our computer and have a look at how well it actually works as a thermal camera. So the first page of the manual, of course, covers how to connect this all up. So it very much is a matter of just going off to the various app stores for your phone to download the app and install it, or to download and install the application then for your PC. And once you've done that, you then just simply need to connect the camera up to your device and we're ready to go. So first off, we'll have a look at the specifications for the actual thermal camera imager. So we have a sensor resolution of 96 by 96 pixels. Now this does sound very low when you compare it to sort of normal image sensors, but for thermal cameras that is quite okay. And we do obviously have the option inside software to enhance that, but we'll have a look at that a bit later on. Now the update of the camera images itself then, so that updates at 25 frames per second, which should give us sort of nice smooth motion as we sort of investigate our objects. It's able to sense in a temperature range of -20 degrees centigrade up to 400 degrees centigrade. And in Fahrenheit then, that is -4 Fahrenheit up to 752 Fahrenheit. So those will give us the actual differences in colours. Temperatures outside of those ranges, then it will just show as either the lower limit or the upper limit. And the accuracy then, so we can actually measure temperatures from the screen image itself, and we will then get a temperature reading then, which is about plus or minus 2%. So when you plug the camera into your phone, it should automatically start up the application, and we should drop into a screen similar to this. So obviously mine has detected that I have my Mini E plugged in. If you're having problems getting it connected, you may see an error message coming up talking about OTG having to be enabled. So that is a special mode that your USB port uses to connect to these sorts of devices. So if that's not been enabled, then you'll need to do that. So have a look through the documentation for your phone to find out how that happens. If it's not detecting the device, there is a little plus button up here which lets you specifically tell it that you have a thermal camera plugged in, and at that point it should find it. But once you've got it all set up, we should then have these 3 buttons across here enabled, and that then lets us know that we can actually start using the camera itself. So as regards the software, so the camera of course has an amount of firmware inside it, and there is an upgrade option here. So this will automatically check the manufacturer's website to see if there's any new firmware for your camera. And of course mine's already up to date, but if not, that will update that for you. You can have a look at your device info, and again you can see sort of what it's seeing itself as. But the most important bit, of course, is our live view. And that will take us out to the actual camera itself, and we can now start to use this as a proper thermal imager. So if we look through the screen then, there's obviously this main bit in the center is our thermal image. And again, we have a number of different modes we can use as regards colours. So in this particular mode here, you can see that we're getting a different range of colours, and I think this one's called rainbow. So you can see on the sidebar here we have a scale, and that scale will auto range depending on what range of temperatures the camera can see. So it really basically sort of says that it makes this dark color here down the bottom the coolest area in the image, and the white then being the hottest area in the image. And again, it will automatically adjust that depending on what you're looking at. So we have some main controls down the bottom here. So this the scale bar, we can turn that on and off depending whether we want to use that or not. We can make the image sort of full size on our screen, and there we have that there. So that's that sort of bit here. We have some image control at the top here as well. So at the moment you can see that we have got quite a pixelated image, and of course that's using the native 96 by 96 pixel resolution. So you can basically see what's going on, but obviously we're not getting such fine detail. So we have a software image enhancement which they've called Super IR. So if we click on that, we can see that we now get a much clearer image. So again, it's picking out a lot more detail in that. But again, this is a software enhancement. It's not truly seeing at this resolution. What this lets us do then is we can now start to take measurements from this image. And again, this is the main reason why we would use this. So if we come down to the measurement options down here, there are a range of things we can do. So we have a range here of point measurements. Okay, so I can select the center point, and you'll see it puts a little cross there, and it's now telling me the temperature at that point on the image is 33.5 degrees centigrade. I can then ask it to tell me which is the hottest point on the image, and you can see there it's found this little integrated circuit down here, and it's measuring that at about 36 degrees centigrade, and that's the hottest point on our image. We can then, of course, find the coldest point on our image, and it's finding it over here on one of the metal connectors. We can then, of course, measure specific points. So if I click on the point one here, I can drop little measurement points onto my device, and I can use a number of those around here. So I could set a number of measurement points which would be specific parts of my circuit, perhaps there might be some sort of resistors there which are getting a bit hot, or capacitors, or some of the integrated circuits. I want to just check the temperature on those. And I can leave those running, and I can see those in real time. So remember, we're getting 25 frames per second here. So you can see those updating quite nicely. And as I run my circuit then, I can actually monitor in real time what's actually happening to the temperatures across that. So this calibrating thing that's coming up at the moment, what it does every so many seconds, it will re-look at the image and recalibrate this temperature scale so that we're always getting our temperature scale matching what the image is seeing. Because again, this particular IC here might sort of suddenly get very hot up to 70 degrees. So it wants to recalibrate itself so that that stays white. And then, of course, we get the rest of the temperatures matching up with that. But that's sort of how we can use the sort of just the point measuring bit there. But we can do a bit more than that. So if I come across here, so we've got the points on there. If I scroll this little menu bar across, so let's clear off those point temperatures. We now have some, in effect, averaging temperature measurement devices. So we have a line, and what that lets us do is we could draw a line across our circuit board, and what it will now do is it will measure all of the temperatures along that line and then give us our sort of averaging and maximum and minimum values up here. So you can see that along that line, the minimum temperature is probably in this area here, of course, at our 19 degrees. And again, our hottest point then is just clipping that integrated circuit there, again up at our 36. And again, our average temperature of that. So again, if you have a particular object which might have sort of hot points and cold points in it, you can use this method to just get the average temperature for that particular region. And again, we have the rectangle tool as well. So let me just clear that. So if I go into rectangle here, I could say, okay, let's have a look at that IC, our main processor. I can draw a little rectangle about that, and you can see there that it's now measuring that we have a hot spot at about 34 degrees, a cold spot at 21 degrees, and then the average temperature for that integrated circuit then at 26 or 27. So again, we have a range of ways in which we can measure and monitor our temperature. So on top of that then, there are a number of other options up here. So these two icons control our auto calibration, and then if we say, if we want to do a calibration now, I can say just calibrate now, and it will then of course reset all of these scales and so on. We can swap the image around a bit, so we can rotate it around as we want to. And of course we then have this other option here, which is the picture-in-picture. So at the moment we are looking at the thermal camera here, and sometimes it's hard to sort of find exactly which point you want to look at by looking at the thermal image, because it is a little bit different. And if this circuit was buried inside a number of other electronics, maybe inside a cabinet or something like that, it might be hard to pinpoint it exactly. So we can do a picture-in-picture. And what this does then, it will show us the camera's optical image so that we can try and get a view on where this is pointing to. Now, of course, I've got my camera set up quite close to my circuit, so my phone's camera is not pointing at the same place. So again, it's there for you to use. But again, it obviously is not an exact overlay of what the thermal camera is looking at. So we do have then a number of other options down the bottom here. So palettes then, as with most thermal cameras, there's a range of ways in which we can look at the image. So at the moment we're looking at a complete range of colors relating to all the different temperatures in our image, but we can start to sort of refine that down. So again here, some of these will be better at giving us an overall picture of what's happening. Some of them will let us see better problem areas, and so on. So let's just have a look through here. So again, we've got the white hot, so white areas are hot, black areas are hot, rainbow was the one we were just looking at. We can then do different color palettes depending on what I guess is personal preference here. Ones which become really useful then, we have here an ice fire. And what this really does then, it uses the sort of white and black to give us general ideas, but then we'll highlight the highest temperatures with this red. And that's very useful then in fault finding on circuits, because obviously most of the circuit will be at different sets of temperatures, but they will be at normal operating temperatures. And what this lets us find then is anything that is at a higher than normal temperature. So again, we did say that that one integrated circuit there was running hotter than the rest of the circuit. Okay, so it wasn't actually in fault, but it was actually hotter than the rest. And again, you can see here that this will then pinpoint that particular area and say, perhaps that's somewhere you need to have a look at. And again, if this was a faulty circuit, so say we had one of our integrated circuits was failing and was generating a lot of heat, then that would of course pinpoint up in here and be very quickly let us identify areas in our circuit that we do need to go and further investigate. So again, other aspects here, again, very much of these then are our personal choice in sort of having a look. It's really just a different way of looking at the circuit with different color regions. So we've got all that set up. We do have then sort of image control. So we do have sort of various controls then, just normal imaging controls. And then the last one over here is parameters. And this is quite important actually. We have a number of, well, parameters, I suppose, which we can tell the system we're using. And that will refine the accuracy of our image. So the first one over here is the emissivity, if you can say it properly, of the devices, of the view that we're looking at. And really what this means is that we're of course measuring infrared radiation coming off the actual objects in the camera's view. Now, different objects will have this different emissivity values, and that will control the amount of infrared radiation that the camera is receiving from that. So depending on what type of surface you're looking at, you do need to slightly adjust the conversion between emissivity and temperature. So at the moment, we've got and this is the standard custom value that it comes with of 0.97, but you can see here for different materials, they have a reasonable range of these values. So these are some ready-made settings that you might want to use. So again, we're looking at a printed circuit board at the moment, so it's better for us if we use that emissivity setting. So that will give us more accurate measurement of what we're looking at. And again, depending what else you're looking at in here, if you're looking at a house, perhaps to sort of measure heat loss in your house or your roof or so on, you would use that one, and so on. So if I confirm that, and we come back into here. If we now, if I go back to my path, let's get us back to where we were before. So we go back to our rainbow, we can see that we now have our white spot there. So again, we were picking it up at just about 36 degrees when we were just using the general purpose emissivity setting. If I now come in here and use my point setting and put it on there, you can see that the real temperature for this one is up nearer the 37 degrees centigrade mark. So again, we by setting the correct emissivity setting, we are getting a more accurate reading. So that's really the camera and its measurement system all set up there. And again, you can see that this is actually giving us a very usable system. So although we are at 96 by 96 pixels, we can still measure very accurately on our device here. Our Super IR setting gives us a much more accurate or a much more high definition view of it. So we can pinpoint individual components like these sort of resistors and capacitors and stuff sitting around here. And then we always have a lot of control over what we can see. So that really is our Mini E thermal camera. I find them incredibly useful for fault diagnosis, especially when I'm looking at sort of old consoles and stuff, which do tend to have heat issues in them. And again, if certain components are failing, quite often on electrical circuits, they do show up as extra heat dissipation, or if they're not working at all, they will of course not generate any heat at all. So both cold and hot points on your circuit are areas for you to investigate. Now, of course, the camera can be used for lots of other things other than circuits, so let's have a look at some uses there. So really the first sort of interesting one was when I actually moved the Raspberry Pi out of the image. And this is a view then of the tabletop after removing that. So you can see there that the Raspberry Pi has created a sort of heat area, and that has left a signature behind in the tabletop itself. So again, just an interesting little point as we're going through here. So obviously the camera comes into its own for anything where we have temperature related events going on. So this is an image of a pot boiling, and you can see that we can actually measure the temperature of the water as the thing is boiling. And again, this would be very useful for, say, something like coffee, if you were making I think coffee is very temperature sensitive to the water being used and so on. So again, comes into its own in these sorts of areas. Now, we usually think of thermal cameras as dealing with heat, but obviously heat is also then related to cold. So here we're looking at a fridge. So this is very handy for checking that your fridge itself is actually keeping your food at a proper temperature. And of course, we can also then move that onto the freezer itself. And again, we're checking here in the internal contents of my freezer compartment. And again, you can see that we're getting a nice low temperature. And again, it's generally matching up with what we have in the temperature sensor on the actual freezer itself. So again, just checking that everything is all okay and working correctly. So that then is pretty much what we can say about our little device. So our HIKMICRO Mini E camera then, as you've seen, it works incredibly well, gives really good image quality, and then of course is very easy to use as regards measuring temperature in a range of situations. And as regards electronics, again, that is quite a helpful tool in diagnosing and testing out circuits. So again, nice price point for that. £120 is not the cheapest you can get. But it's by no means not the most expensive you can get. These things do sort of go up into the thousands. But in terms of then what you can do with it for the money, I think that is really good value. And again, it's a really good quality device as well. Some of the other ones that I've tried are higher resolution, and yes, they are higher resolution and give you a finer detail on your images. But again, you can do pretty much everything on those on this one as well. Just of course, just that fine detail that you're lacking. So again, very good compromise and very good product. So I hope you found this video useful. If you have, please do click that like button and subscribe to the channel. And don't forget, I do much more sort of electronics reviews, making videos, circuit videos, and then sort of gaming and modding videos as well on consoles. So do check out some of those. I look forward to seeing you again in another episode very soon. And bye for now. For more games programming, electronics projects, and retro gaming, please make sure you like this video, subscribe to my YouTube channel, and visit my website.